Today's lesson is Module 1, Topic 1, Lesson 2, Formal Reasoning in Euclidean Geometry. Let's go ahead and start with our definition of a conditional statement. Conditional statements are statements that can be written in the if, then form. They can be true or they can be false. Let's take a look at an example. If you work hard, then you will like geometry. We're going to see that very classic if-then format. We're going to start always with the word if, and then we're going to learn what this part of the sentence is in just a moment. We're going to see a comma after it, and then we're going to see the word then, and we're going to learn what this part of the sentence is as well. Now, you might have a different take on if this is true or false, but if you can come up with one reason why it's false, then it is false. A conditional statement has what is called a hypothesis. This is the if part of the statement. The hypothesis is the if part of the statement. So the word if is going to identify the hypothesis for you. I like to circle it, and then the words after it are the hypothesis. So you work hard would be considered the hypothesis. However, if you do say if you work hard is the hypothesis, I would give credit for that. Okay. I'm just trying to pick a color here that's different from, let's go with green. And it has what is called a conclusion. There we go. So a hypothesis and a conclusion. The conclusion is the second part. This statement down here that I'm highlighting is if P, then Q. So if the hypothesis, then the conclusion. I like to box in the word then. Then is an identifier for our conclusion, just like if is for our hypothesis, and everything that comes after it is going to be our conclusion. So our conclusion would be, you would like geometry. We also have what are called equivalent statements. These are two statements that are both true or are both false. A conditional statement and its contrapositive are what we call equivalent statements. Don't worry, we're going to learn what a contrapositive is in just a moment. Also, the converse, we're going to learn that today as well. And the inverse, we'll learn this one as well, of any conditional statement are also are equivalent statements, both true or both false. Before we can get into the converse, the inverse, and the contrapositive, we are going to do the converse first. So the converse, let's go down to the bottom here. The converse is formed by switching the hypothesis and the conclusion. So if you notice, the conclusion is now first, Q is now first, and the hypothesis is now second. Let's take a look at our example up above, and let's see if we can write the converse. If B is between A and C, then AB plus BC equals AC. So let's go ahead and identify the hypothesis and the conclusion of this conditional statement. So remember, we circle the word if, and then everything after it until we get to the parentheses is the hypothesis. Then we box in the word then, and everything after it till the period is the conclusion. Now we're going to go ahead and we're going to leave the structure of the sentence. So the circled word is going to stay the circled word, and the boxed word is going to stay the boxed word. So we're going to go ahead and start with if, but we're going to switch to the conclusion. So if AB plus BC equals AC, and because the format calls for a parenthesis at this, or sorry, a comma at this time, we're going to put the comma. We're going to leave the word then, and we're going to put the conclusion. Then B is between A and C. And we'll, of course, end our sentence with a period. Okay. Now, it's not necessary for you to use the color. However, it is helpful in seeing them actually switch with one another. All right, before we can move on and do the inverse and the contrapositive, we need to talk about the negation. The negation of a conditional statement is the opposite of the original statement. Notice that we're still seeing our conclusion here, or sorry, our hypothesis, but we've added this little swoop in front. We read that as not the hypothesis. So to do the negation, we are simply adding, if you want to add this to your notes, adding not to hypothesis and conclusion. Okay, it's very important that you add not to both. Let's go ahead and look at our example. It is raining. Now, I know what you want to say. You want to be very, very creative and give other examples of weather that is not raining. It is sunny. It is windy. It is snowing. Although all of these are different from raining, they are not the opposite of raining. The opposite of raining means we simply add the word not. So our negation would be, it is not raining. And that's it. It could be snowing, it could be sunny, it could be windy, it could be sleeting, it could be anything. But all we know is that it's either raining or it is not raining. Now, I know what you're thinking. What if the word not was already there? Would it make sense to go from here, from our negation, and add not to it? Well, let's just say it out loud, because we would have to add another not right here, right? Or right here. So we would read that as it is not raining. That sounds funny, right? You wouldn't say, oh, no, it's no raining, right? You don't want to say it is not raining. So what you're going to do is, if not is already there, you're going to take it out, and we come back to our original statement, and they would be negations of one another. All right. To do the inverse of a conditional statement, it is formed by negating both the hypothesis and the conclusion. Both the hypothesis, so notice there's my hypothesis and it's been negated, and the conclusion. Okay, notice both of them are saying if not the hypothesis, then not the conclusion. Oop, I forgot to color it. There we go. All right, let's go ahead and take a look at our example. If it is sunny, then it is hot. Remember, you want to go through and you want to identify the hypothesis and the conclusion as they are first. You want to make sure you know, nope, I want to circle. There we go. You want to know what the hypothesis is, and you want to know what the conclusion is. All right, and now we are ready to write our inverse. What's helping about the color is it's helping me to see, should I switch them, right? Like in the last one, we wanted to put the green first, put the conclusion first, and we wanted to put the hypothesis or the purple second. So they needed to switch places. In this case, we're keeping the purple hypothesis where it is, and we're keeping the green conclusion where it is. We are simply going to add the word not to both of them. So here we go. Let's give it a try. If it is not sunny, then it is not hot. Okay, very important that we make sure that we add that word not twice. There are some instances where the word does not or do not or is not would be a better fit than just the word not. But for this one, since is was already there, we're just simply going to add the word not. Our final form of our conditional statements is called the contrapositive. Let's go down here. Our contrapositive is formed by switching and negating the hypothesis and the conclusion. So we're going to take our hypothesis and we're going to move its position, and we're going to take the conclusion and we're going to move its position. We're also going to add the word not. So we're going to change it from if hypothesis then conclusion to if not the conclusion then not the hypothesis. This one is tricky. It involves doing both the converse and the inverse at the same time. So let's give it a try. If two angles are vertical angles, then they are congruent. Let's identify our hypothesis and conclusion. Go ahead and pause the video and see if you get the hypothesis and the conclusion correct. Remember, we're circling the word if, and everything until the comma is our hypothesis. We box in the word then, and everything after it until the period is our conclusion. All right, so we're going to switch the colors, switch the conclusion and hypothesis. We're going to keep the circle and the box where they are. Maybe it might be better if we didn't circle them in the same color. We just circled and we boxed, right? Because they don't move. They don't move. They help me identify, but they do not move. And that's why I like to circle and box them, because we don't want them moving. We're also going to add the word not. Sometimes it makes more sense to say it out loud before you actually write it down, just to make sure that you have it right. I'm going to slide out my screen really fast just so that we can see the color at the bottom to make sure that we are switching and putting the green conclusion first and the purple hypothesis second. Do not forget to negate. All right, here we go. If they are not congruent, then two angles are not vertical angles. Perfectly fine sentence. That would work for me. You also could say if two angles are not congruent, then they are not vertical angles. That would work as well. All right, but I think I'm going to keep it as it is, and I'm just going to say if they are not congruent, I'm going to put that green conclusion first, then, and now I'm going to go to the purple hypothesis. Two angles are not. That's a perfectly fine place to end it, or you can just go ahead and finish with the words that are there. Okay, making sure that we've added those words not, I'm just going to come back in and underline them just to make sure that I put them, because that's what the contrapositive means. It does not have to be done. It's just there for me as a check to make sure that I've done it. All right. Let's go ahead and practice. Okay, so pause the video and see if you can write the converse, the inverse, and the contrapositive of this statement. If you are a teenage girl, then you like Justin Bieber. Let me help you out just a little bit so that you can be successful. All right, I'm not going to take the time to write these down here in the video, but the converse would say, if you like Justin Bieber, then you are a teenage girl, because remember, in the converse, we're going to take and switch the P, the Q, and the P. We're going to take and put the converse, the conclusion first, and the hypothesis second. In the inverse, I'm going to keep the order as it is. I'm going to add the word not. If you are not a teenage girl, then this is where I would put do not like Justin Bieber, because you not like Justin Bieber doesn't make as much sense in my ear. For the contrapositive, I would switch and I would add the not. So if you do not like Justin Bieber, then you are not a teenage girl. All right, so we also have what is called a counter example. And a counter example is a very specific example that shows that a general statement, I forgot the S, that a general statement is not true. All right, so we could go back to our statements about Justin Bieber and we can talk about whether they're true or false. Maybe even from the beginning really quickly. To be a counterexample, the converse must stay true. So you have to be a teenage girl, okay? But you don't like Justin Bieber. That you would be a counterexample. Now you could use someone very specific. Let's take a look at these two counterexample statements right here. All prime numbers are odd. If we go to look up all the prime numbers, a list of the prime numbers, we would see that the majority of them are odd. But the very first prime number is 2. And so 2 would be considered a counterexample because it is prime and it is even. So there's my counterexample, 2. How about this statement? The sum of the measures of two acute angles is always greater than 90 degrees. Well, if I remember correctly, an acute angle is less than 90 degrees. Although that is true for a lot of acute angles, 50 plus 50 is 100. That is true. What about 30 degrees plus 35 degrees? This is only going to add up to 65 degrees. And there's my counterexample. I have two acute angles that when I add them up, their sum is less than, not greater than, 90 degrees. We are going to be learning this year about postulates and theorems. Postulates are rules that are accepted without proof. We've just all believed that this is how numbers or segments or angles behave. Theorems are rules that must be proven, that we can prove. This type of geometry that we are studying this year is called Euclidean geometry. Euclidean is a Greek mathematician, Euclid is a Greek mathematician. He used a small number of undefined terms and postulates to prove many theorems. Euclid's first 5 postulates are: a straight line can be drawn joining any 2 points. Any straight line segment can be extended infinitely in a straight line. Given any straight line segment, a circle can be drawn that has the segment as its radius and one endpoint as its center. All right angles are congruent, and if 2 lines are drawn that intersect a third line in such a way that the sum of the inner angles on one side is less than 2 right angles, then the 2 lines invertedly must intersect each other on that side if extended far enough. This postulate is equivalent to what is known as the parallel postulate. He also had the elements, which includes the 5 common notions. So things that equal the same thing also equal one another. If equals are added to equals, then the wholes are equal. If equals are subtracted from equals, then the remainders are equal. If things that coincide with one another equal one another, and the whole is greater than the part. It's important to note that Euclidean geometry is not the only system of geometry that we could study. Some examples of non-Euclidean geometry include hyperbolic, ecliptic, and spherical geometry. The essential difference between Euclidean and non-Euclidean geometry is the nature of parallel lines. So let's go ahead and take a look at our parallel lines. Here in Euclidean geometry, lines that remain a constant distance from one another are known as parallels. So these would be considered parallel lines. However, in hyperbolic geometry, the lines curve away from one another when they are parallel. And in elliptic geometry, the lines will curve towards each other. Now, those 2 geometries are not as widely studied as spherical geometry. Like its name implies, this is a geometry that substitutes a sphere for a plane, which makes it different from Euclidean geometry in many different ways. Due to the spherical geometry existing on a sphere or a curved surface, some topics that we will learn about this year, such as parallel lines and the sum of interior angles of a triangle, are very different. In spherical geometry, lines are defined as great circles, so they look a little bit different than what we talked about in the last lesson. In spherical geometry, triangles have different properties as well. Let's go ahead and consider this spherical triangle shown. It has 3 right angles. That can't happen in Euclidean geometry. That is happening because of these curved lines that we're seeing here. This is the great circle that they're talking about. It has 3 right angles, so the sum of the interior angle measures is 270 degrees. In Euclidean geometry, we're going to learn that a triangle is always 180 degrees. And of course, as I've stated, the sides of a spherical triangle are always arcs of a great circle. So that just means they're part of a great circle. They go like that. All right, so For our last list example here, let's describe some similarities and differences between triangles in Euclidean geometry and spherical triangles. One of the major things that I noticed is that in spherical geometry, a triangle can add to more than 180 degrees, and in Euclidean geometry, a triangle is 180 degrees all the time. I've also noticed that in Euclidean geometry, the sides are straight. The sides are straight. And in spherical geometry, our sides are curved segments. All right, Tigers, we've come to the end of our lesson, so I'll see you in the next one.